Let us look at proposition number 58 of book 10 of Euclid's Elements. The proposition says, if an area is contained by a rational straight line and the fifth binomial, then the side of the area is the irrational straight line called the side of a rational plus a medial area. Okay, let's proceed how to prove this. And in the process, we'll learn what this proposition is talking of. Let the area AC be contained by a rational straight line AB and a fifth binomial line AD. Divide AD into its terms at E and let AE be greater than ED. Let's do that. AE and ED are rational straight lines commensurable in square only. AE square is greater than ED square by the square on a straight line incommensurable with AE, and AE is commensurable in length with AB set out. Now all these three statements are based on the definition of the binomial, fifth binomial line. Bisect ED at F. Apply to AE a parallelogram AG by GE such that it is equal to the square on EF. Okay, so here AG by GE is equal to EF square. Now, because of this, we can say AG is incommensurable in length with GE. Now, draw GH, EK, and FL from GEF parallel to either AB or CD. H, K, L, and instead of drawing the lines, let me color them differently. Construct SN equal to AH. So basically, we are constructing a square SN whose area is equal to AH. So this area is equal to this area. We construct NQ equal to GK, and we construct it in such a way that this line continues, and on that we construct this square NQ. Now complete the parallelogram SQ, the complete. So basically we have to complete this rectangle and we have to complete this rectangle. So based on the lemma that we saw in proposition 54, we can say SQ is also a square, and AG by GE is equal to EF square. That means we can write it in proportionality terms as AG is to EF equal to EF is to GE, which means EF is the mean proportional between AG and G, which means AH is to EL equal to EL is to GK. Why? Because AH is the figure on AG, EL is the figure on EF, and GK is the figure on G. So we can say EL is a mean proportional between AH and GK, and EL is a mean proportional between SN and NQ, because AH is equal to SN and GK is equal to NQ. And again, based on the lemma, we can say MR is also a mean proportional between SN and NQ. So we have EL is equal to MR is equal to PO also, because MR is equal to PO. AH plus GK is equal to SN plus NQ. These two are equal. These two are equal. So since the remainders are also equal, that means this entire rectangle AC is equal to the entire square SQ. And this square can be written as SJ square, square on SJ, or we can also write it as MO square. Why? Because SJ is equal to MO. So AC is equal to SQ is equal to the square on MO. So which means MO is the side of AC, or more elaborately, we can say MO is the side of a square whose area is equal to the area of AC. AG is incommensurable with GE, So AH is incommensurable with GK because AH is the figure on AG and GK is a figure on GE. So is SN with NQ because AH is equal to SN and GK is equal to NQ. So we can say MN and NO are incommensurable in square because SN is MN square and NQ is NO square. Now, since AD is a fifth binomial line and ED is less than AE, ED is incommensurable with AE. ED is commensurable in length with AB. That means AE is incommensurable in length with AB. So, AE, AB, they are incommensurable. That means the area contained by them, AE by AB, is medial. That means AK is the area contained by AE and AB. So AK is medial, which means MN square plus NO square is medial because AK is equal to SN plus NQ. SN is MN square, NQ is NO square. So MN square plus NO square is medial. Now ED is commensurable in length with AB. That is EK because AB and EK are equal. ED is commensurable with EF because F is the midpoint. So ED is a multiple of EF. Now, since ED is commensurable with EK and ED is commensurable with EF, that means EK is commensurable with EF. Since EF and EK are rational, how are they rational? Because ED is commensurable with AB, which is equal to EK. ED is commensurable with EF, EK is commensurable with EF. So that means EK and EF both are commensurable with AB, which is rational. So that means EF and EK are rational. That means the area contained by them is also rational. Now, so MR is also rational. Why? Because MR is equal to EL. MN by NO is rational. That means why? Because MR is contained by Mn and Nr, but Nr is equal to No. So we can say Mr is contained by Mn and No. So that means Mn by No is rational. And Mn plus No is equal to Mo. So Mo is the side of a rational plus a medial area. So medial area is this and rational area is this. So that is proposition number 58 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.